Start recording. Okay, so again, my name is Eric. I'm the demo tech, and we're going to be going through the webinar today of 3D CAD modeling features and certain 3D CAM milling, 3-axis milling features. So again, my name is Eric Seckler. I'm the demo tech, and I've been doing demos for I'd say about 3 years at least, 3 to 4 years. I've been with BobCAD for 5 years now, and I have this is only my second webinar, to be quite honest with you guys. First one went pretty well, I think. If anybody, any of the attendees today, if they were in the first one, let me know and let me know what you guys thought of it. I know there were a couple guys that said I did decent last week, so they brought me back this week for a second webinar here. Last week we went over 2D CAD features, some very basic ones: creating text, modifying text, fitting text to a curve, 2D Boolean creation and subtraction, and what else did we do here in Create 2D? We did pretty much all of the sketching options here: point, line, arc, rectangle. So we're kind of leaving off from there, of creating 2D shapes and then creating 3D models from it. Basically, what it looks like here in the notes, mostly the 3D CAD functions are going to be going over extracting edges to create 3D wireframe, changing any type of geometry from one layer to another, changing layers, making them active, making them hidden, and let's see, section view and silhouette that we have now, those two 3D wireframe creation options now. And when it goes to 3D 3-axis milling, we left off from last week of doing 2-axis milling, doing a pocket on the inside of a part and doing the outside profile. We're going to be going into the 3-axis machining, 3-axis milling, where we can go over some features in the 3-axis standard and 3-axis pro of the 3-axis roughing milling operations today also. So let's start from there, where we can go to this part file here. We can start by extracting edges to create 3D wireframe, creating multiple layers in here, certain features like that. Let's see if I can hide this for now. That works. Okay. So we've got a 3D model here. I want to extract the edges of these surfaces. If I wanted to create a wireframe, create some wireframe around this, I'm going to avoid this area though. I just want to focus on this area for this operation here. Or I guess you could say, look at the scenario of creating a boundary for just this geometry in blue now. I'm going to highlight all of the surfaces and right click anywhere here in space, and we have this option for modify attributes. We're going to be going through these options here quite thoroughly, and the first one here is color. We can change it from the blue color that we have currently and change it to a gray color. Not 100% sure on which gray color this is, but not a huge difference, and we're not going for looks at the moment. We're just going for the utility of extracting the edges of these surfaces, creating a boundary so that we can do a surface finish operation on just these surfaces here and avoid any air cutting, avoid any machining that that doesn't need to be done on other surfaces here. So to start with that, we have our target surfaces. They are being shown here with that eyeball icon. I can hide it by clicking on that icon again for it to go away, for the surfaces to go away here. And to create a new layer, we right click here in this layers window, go to add new layer. That'll be layer 5. I can rename this layer if I want to just by clicking in the box there, and we will say webinar. Again, you can just name it any type of name you want for the layers to distinctly know which ones you were previously working on. And we can go here. I'm just going to right click out here and cancel everything, just in case I was in any CAD functions. I know I was in the select mode function, so I just canceled out of that. I'll go up to the top, go back into select mode, and highlight all of these surfaces. Just by clicking on each one individually, we can right click and go to modify attributes again. We have the color option that we went through. We'll go through the line style option because there's nothing that we're going over today with line style. But we'll click on that. You can change from a solid line to different dashed line options. Then we'll go back in. I'm just going to cancel, go back into the select mode, and highlight each of the surfaces there. And whichever one I click on and accidentally highlight that I don't want, I can just click on it again to deselect. You notice that I am selecting each surface individually. This is because if I window select one, it's going to window select everything behind it. So I don't want to do that. That is why I am individually selecting, because if I window selected this guy here, I'd be window selecting the other surfaces behind it there. So again, individually selecting all of the surfaces, then right click and modify attributes. Color, line style. We'll go through point style here also. Yeah, we'll just get that one out of the way. So we'll go to select mode. I'll select an existing point, modify attributes, point style, instead of the classic style that we have there for the points. We can select any of these other options to highlight points a little more easily, or distinctly find where any points are in the CAD workspace, and also change the point size. If I wanted to change it to 1/4 inch, for example, I can change it to very large points. You know, it can be frustrating trying to find them sometimes, so it's a lot easier to find one that is 1/4 inch in size here. So I'll change it back to this one. Yeah, the point size doesn't matter for that classic point style, the generic one there. So from here, we can finally go to selecting our surfaces. Select mode, individually select our surfaces again here. Right click, modify attributes, and layer. Now I can put these surfaces on whatever layer I want them to be on. Target surfaces, the webinar, target surfaces layer, the webinar layer. I'm going to keep them on target surfaces just because they're already there and they're already separated from anything we're already trying to do. But I'm going to put the wireframe from the extract edges CAD function I'm going to be going over onto the webinar layer so that we can distinctly have them separated from everything else there. So keep it on target surfaces. We'll hide the layer for CAD just to see what we have for target surfaces there. I think the CAD layer has everything there in gray. Okay, so I haven't changed that one over. Maybe I'll give an example of that. Just going to select mode, selecting all of these surfaces, and I'm going to move these over to the CAD layer, since I'm only going to be selecting or doing machining as a scenario, a finish operation for those surfaces there. So we'll go to layer, and go to the CAD layer and add all of them together there. Now it'd be even easier if I went to my select mode, and now I can window select these surfaces on the target surface so that I can change it to the CAD layer. So from here, we can go to extract edges, and we can go to, so that's under create 2D, extract edges. We can pick the whole solid. So this isn't stitched together, so it's not going to allow us to pick the whole solid just by clicking on it. But if we went into create 3D, stitch surfaces to solid, selected it, solidified it, we can pick the whole solid automatically. We can window select surfaces, window select the whole thing in here. I'm going to individually select each of these surfaces here, get the wireframe from it, and we will see what it does to start off with. We'll see what it does when we select each of these surfaces here. Click OK, and then hide. Oops, I actually kept the target surfaces layer active, so I'll undo that. I'm also going to take a second to save and tell everyone to save periodically, because CAD software programs tend to slow down, tend to stop responding sometimes, and in case there is a power outage or anything else that happens inconveniently, you'll have your work saved. So I'm going to extract the edges from the surfaces individually selected here. I'm going to click OK and double check that the webinar layer is active. So I'll click OK. I'll cancel out of the CAD function and hide the two layers here to see the wireframe. And now it picks up all of the edges of the surfaces that I've selected. Picks up on the inside here too. You don't necessarily need that for a boundary, and it's also kind of in the way if I want to chain select, which is what we're going to be going over next. So interfering with chain selection can be quite bothersome. So I'll just I can window select each of these entities. And just hit delete on my keyboard. That way I can chain select all of this here. If I go into my select mode and chain select, it is holding shift on your keyboard and clicking on one entity. It'll chain select the whole chain of entities that are tied together here. So one closed loop of geometry will be selected all together when you hold shift and click on one entity. It'll get everything there. Now if it is, I'll undo this and go to some other extract edges options first. So we'll go to extract edges, and I could select all of the entities instead of having to delete all of them after creating the wireframe. I can just click on the outside edges of the surfaces to create the wireframe from the outside edges only. Also, I can project to a Z-plane. So I can flatten all of this wireframe to a certain plane above this or below it or somewhere in between. I think Z0 would be okay, but let me check where Z0 is here. Not 100% sure. I can go to Settings, Current Document, and then Display to show the axis and the gnomon on this again. So the axis, show axis, will be showing the X and Y axes here, the grid. Show gnomon is this XYZ representation here to show where the CAD origin is. Some other options in here can be very helpful. Number of tick marks for the axis in X and axis in Y. Shading quality and wireframe quality. This can help if there's any kind of bad geometry that appears in the file. It's not actual bad geometry. You're just seeing it as that. If there's any gaps or anything that isn't actually there, but visually it is, I guess you could say. You're going to the wireframe geometry and moving that up to help with the quality of how the CAD model looks. It puts a it applies more necessities from your video card, but as long as you have the right graphics card, one that's very powerful, it'll be able to handle any type of wireframe requirements that you might need, or shading, 3D surface quality in those options. So again, we're looking at Z0 is going to be right here on the plane where the X and Y axis is. So I'll project to that Z plane. I will want it there. And I'm just going to hide the two layers of the surfaces. Click OK. And that's the wireframe it comes out with. If I look at it from the front view, it's completely flat right at Z0. So we'll take a look at the chain selection. Kind of go back and forth, I guess, with these extract edges and then the chain selection here. Kind of go pretty well together. So we'll go to Utilities, and I'm going to trim away a little bit of this line here. There we go. Okay, so it's trimmed away a little bit. Obviously you can see this gap, but if there was a very tiny gap that you couldn't see or anything crisscrossing each other here in this chain, we could go to our select mode, hold shift, and click on one entity. It will chain select everything up until that gap. So it didn't select this extra arc here because it wasn't a closed chain to select everything here. It started from where I clicked on all the way out to the gap. If there was more geometry, for example, if I started here, it's going to go all the way out to here and stop and not select anything else following around from where I selected. This is very helpful where you're trying to create a pocket of some kind of geometry, like a slot here. If you're trying to chain select around a profile, and you think you've selected all of it, you window select it all and click OK and compute the toolpath. It's not going to work very well, or with Pocket, I don't think it will actually compute the toolpath. It's where you have an issue there because you haven't closed off the geometry for selecting the geometry of the actual pocket. The software doesn't understand you want to pocket this, but everything outside of it also is everything. So anyway, that is why the chain selection is very, very useful. It will also tell you any areas that haven't been closed up for your geometry yet. Another one with chain selection, one other option here is selecting a specific chain, not chain selecting all the way around the given geometry here, but you can click on one entity, for example, and I want to go out to this corner. I clicked on this line, and then I'll hold Shift and click on the arc, and it will stop right at where the arc is. So if there's a lot of geometry you're trying to get around the line, going around all the way out to this line, I hold Shift and click and get all of the geometry there. So after that, to explain or to specify that a little bit more, going into the select mode, I am clicking, just to be sure with you guys, I'm clicking to this area halfway of the line, not this area. And that way the software knows that's my start position of the chain selection. And when I hold Shift and click, I want to just select this line, this arc, and this line. I want to hold Shift and click in this area of the line of this halfway mark to chain select it correctly of what I want it to do. If I do it the opposite way, if I hold Shift and click on this area of the line halfway, it's going to try to go around, I believe, let me make sure. Yeah, it's going to try to go around the opposite direction. It's also kind of weird because it doesn't select this arc, which can be helpful showing that there's a gap in the geometry still, but also try to chain select of what you're trying to do there. So again, you want to select this entity and then make sure when you hold Shift and click that you're clicking on the specific direction you want it to go. You want it to go around clockwise. You hold Shift and click to the direction where it's going to end. And if you want it to go counterclockwise, just this line, this arc, and this line, you hold Shift and click on the line somewhere in this area from the halfway mark. Okay, so chain selection, extract edges. I think we went through everything there. Pick whole solid, select any geometry of surfaces or a whole solid. And we can also project to a Z-plane to flatten it anywhere there in the CAD workspace. Okay, so chain selection, extract edges, select mode, layers, and creating groups in the layers as well. If you wanted to create the wireframe, which I'm going to go back to having a full profile with that in the webinar layer. And then say I want another layer of webinar 2 and more wireframe for that one. I'll just look at this CAD layer and I just want the edges of the top surface there. I can project or not, it's going to be the same thing because it's at Z0. And then one thing to be wary of here is since we are extracting the edges from a shared edge here, we will have double entities. So if I go into my select mode, click on one of these here, hit delete, it will still have a line there is I created 2 lines, one from the time I created it from target surfaces, and another line at this point when I created a line from the CAD layer. So just something to look out about the extract edges function. And then I have 2 layers here, one for webinar, one for webinar 2. Oops. There we go. And I can add new layers here. I can also create a group. So if I insert group, I believe I should be able to drag and drop them in. Or I might have to create new layers from there. That might not be an option yet. You can drag and drop them. Nope, you can drag and drop them in. It just has to be at the right location. You can sort the layers here any which way you want, and you can also drag and drop them into a group. There we go. So in group 7, or I'll just name it group 1 here, we've got webinar layer and webinar layer 2, which I can hide all of them together. Oh, that one's active. There we go. So I can show all of them together, hide all of them together. Can't make all of them active. You can only make one layer active at a time. So we have select by layer. Select modes, extract edges. Moving geometry to another layer. I believe we went over that also. Just if we wanted everything on webinar 2 now, I can go into my select mode and highlight everything. Right click in the CAD workspace, modify attributes, layer, webinar 2. So now everything is on that webinar 2 layer now. I can hide all of it, show all of it. Okay, so chain selection, done that. Move geometry to another layer, done that. Sorry, just going over my notes. I'm gonna say this one other time. It's my second webinar. I normally do demos of the software program, so normally I'm only brushing up on certain topics. I'm not normally going very in-depth with any CAD functions, or really any CAM functions for that matter. So yeah, just kind of bear with me here. It takes a while to for me to get really in depth, kind of changing gears there from doing demos to webinars here. I'm going to go into see if we've got any questions, see if we've got any comments here now. I wonder why the questions. Let me pop this out. There we go. Awesome. Bradley, that's a great point. I will have, you know what I could do for next webinar, for having the file for you guys to go and follow along with me. I will have, I'll download it on a Google Drive link, and I'll put it in the comments section so that you guys can just copy the Google Drive link, copy and paste it to work on the file at the same time with me. That's a great point, Bradley. I'll do that next time. I have a request saying how you would do something. It would also Mark saying you got something to do with the 4 or 5 axis Pro package. Questions on that? That's fine. Go ahead and any kind of questions you guys have in the comment section, I can, if it doesn't pertain to the webinar today, I can read them at the end of the webinar, and I can either answer them for you guys. I'll take some time after the webinar to answer any questions, and also if there's anything pertaining to maybe next week's webinar or anything like that, we can go over that too. So we'll go through a couple other 3D CAD functions. Funny, the ones we went over are under Create 2D. We'll go to Create 3D. We have, let's see, I'm tempted to go through my spiel of a demo, so I'm got to go back to my notes here. Section view and silhouette. Silhouette is a new 3D CAD function, very similar to section view, but you can extract more edges from surfaces to wireframe in that, more with holes inside of a part and any other kind of cavities inside of a part you can extract the wireframe from in silhouette a little more easily than section view. Section view, it's got to be right on, right in the area. We can go over that right now. The section view here, let's see. We'll go to Create 3D, or it might be, I think all of these are under Create 2D. Yep, Create 2D. We have our silhouette feature, that's the new one. And we have section view right here. All right, so we can select the solid. Again, this is not stitched together, so with these functions, it's going to be a little easier to go to Create 3D, stitch surfaces to solid, and window select the surfaces, and click OK. Now it's going to stitch it all together. It's all going to be under that webinar layer that was active. And it's going to change the color to the default color of blue. For me, it's really too hard to see anything on the inside, those surfaces. So I'll go to select mode and change the colors. Oops, there we go. Color back to gray. And let's see. These essentially have nothing on them, I believe now. Yeah. Those really have nothing on there except maybe that point. Because when I stitched all the surfaces to a solid, they all have to go to one solid, and that solid has to go to one layer. It's not going to go to one by default. It's going to go to the one layer that is active, and this webinar layer was active instead of the CAD or target surfaces function layers there. So that stitch surfaces to solid function created the solid onto the webinar layer, so that's what I'm working on now. And I have that webinar 2 layer to hide and show the wireframe there. So we'll go to section view now. We can select the solid. We can confirm selection. We can pick a plane or a certain UCS that we're creating the section view from. So a plane is one that you can select from a surface, from a flat surface, I should say. Or the UCS, we're on the top UCS right now. From the drop down here, I can select front UCS, so we can get the section view from this half, or the side view here. What I could do, some guys have done in the past I've seen, that can be pretty cool. I'll create a couple layers here from the group. Add new layer, add new layer. So we've got layer 8 and layer 9. I'm going to make layer 8 active first and create a section view on this layer, then create a section view on the next one. I've seen that in the past before and thought that could be quite useful if there's some type of, especially I think with turning, if you're going to be doing turning on the ID, you want to see what, oops, reset. There we go. You want to see what's in the inner diameter of the turned part in certain areas. So it can be very useful getting all these different section views here, or section views inside of the pockets here can be useful. So you've got that one from the front. I'm going to rename them. Excuse me. I'm going to rename them to front and side. Hide the one that we just made, and go to section view, and this is going to be from the side. Create wireframe. And I know you can drag it over from there. So if you wanted to get the wireframe from the holes here, for example, you can also manually change the distance here. So if you knew it was negative 575 here, for example, that's the exact point you wanted. And then create wireframe, you can reset, so it'll go back to that Z0 level, or the distance 0 level, and cancel out of the function there. So here's the side view, the front view from Z0, and the different surfaces there, or the different edges and then surfaces. Okay, so going through section view, I think that's about it. You can also rotate it if you want in the Y direction, or you can rotate it in the X direction. We got some kind of cylindrical, spherical parts, certain things on the inside you want to see. You can create the wireframe for that. And also this helps if you're creating prints too. So if you've got, and I normally show this in a demo, admittedly, but I will translate this over. So I've got my part file, I've got my front and my side views. I'm just going to do the front view to make it easy here, and I'm going to rotate it to make it flat on the Z0 plane here, on the top plane. So I'm going to select the geometry, and then from the arrows, from XYZ, it looks like I want to rotate it in the X direction. It's going to be negative 90 degrees, or what does that look like? 270, I believe. So negative 90, and then click OK. And that way you can, go in, translate this over, click OK, and then go into evaluate, go into dimensioning for this. You can get the total distance here. You can get the total distance by clicking on one point and then clicking on another point out here to get the total distance, or just click on a line here to get a distance of that. Also, you can go into note and go into typing in your text for section view A, for example. I'm going to be very basic with it, and click on a point and create my note there. I can create that note, if I created an isometric view of the solid model, or a different view, I believe from the side would be easier to see, but essentially I think we're looking at it right from here. So you can just click on that point and create that note in there as well. That way, if we needed to create a print of it, we do have default template files. Kind of what I was getting at. If you go to File and then Merge, it's through a long file path. I'll go slow with it, if you guys want to find where these template files are, you go to this PC, C drive, don't have much memory left, BobCAD-CAM data folder, BobCAD-CAM V34, or if you're using BobCAM for SolidWorks, BobCAM for Rhino, those should be Rhino files, I would imagine. Sorry. Okay, let me start from the beginning here. So File, Merge, and again, this is something you guys can follow along with. These template files are in every software package of BobCAD. If you go to this PC, C drive, BobCAD-CAM data, BobCAD-CAM V34, examples, and title blocks. All of these files, they each have a border for the drawing. Oops, let me try to open that again. It didn't do what I wanted. So again, this PC, C drive, BobCAD-CAM data, 34, examples, title blocks. And let me select a different one then. Let me just select this guy here. Let me try a different, maybe something wrong with the layer. I don't know. Merge. Maybe something to do with this file. Anyways, merging files normally is easier than that. We go to File, or you could even go to Open, and you can merge this geometry from the file. That could be helpful too. So we'll just go to Open, C drive, BobCAD-CAM data, 34, examples, title blocks. And just open up the template that we have. So if you look in the corner here, the scaling, the revision number, sheet number, model, drawn by, checked by, and you can go in, you should be even able to change the text here, possibly entity modify. Yeah, so this is all different text. We can change it from the BobCAD default text to any other Windows font or anything else. Change the size, change the text here. And what you could do is you could just go into select mode, Windows select everything, Control C to copy, and then Control V to paste. So that is holding Control and C for Charlie, or C for copy, and then paste is Control V for Victor, or Control V for paste there. You can also do it here at the top if you guys aren't as computer savvy, which is okay. Just go to Home and copy, and then you can go to the next file, Home, and paste. You can even go old school with it and go to Home and cut and paste, but I don't think you want to cut all the time, especially with CAD geometry that you've worked so hard on. It's going to go away if you cut and then paste into a new file. So yeah, you got the copy paste option there, and then again Control C and then Control V. There are other shortcut keys in here that we can be aware of too. In here, looking at, I'm trying to get back to everything here. There we go. And actually, let me undo for the section view and the dimensions there. And then one more. There we go. I'm trying to bring my solid back here. There we go. So from here, I'm sure it's not in. So Sorry about that. Let me just translate it back. I'm not sure where it went afterward. Just translate it back to the CAD origin there. Okay, so we've got target surfaces, side, front. So we went through the section view, and now we'll go to the silhouette function. Again, very similar to the section view. When we go in, let's see if I've got anything. Okay, so it's on webinar. Okay, so layer 10, I'll rename this to silhouette. Figure out how to spell silhouette. And then selecting the solid model. We have a few different options. Pick an existing UCS, pretty much the ones we went over already, selecting the direction, the top view, the front view, the side view of it. You know what? We were looking at the front view. We'll look at the front view of it here, and we can merge all and internal shapes. So let's start with internal shapes. This is going to kind of what it's saying here, extracting all of the edges for wireframe for your section view with all of the internal shapes of the solid model also. So all of these lines and arcs here, and with the corner radius, those two edges should pick those two up, should pick these two up. But let's see how it looks here. We'll click OK to start with that. It might just be the outside. Okay, so it's just the, where is it? Yeah, so it's just the outside currently. Let's go back to silhouette feature and change that. So it might be the opposite type of, well, let's see what merge all gives us. Merge all is coming from the top, existing UCS, front. Oh, it may, okay. Let's do it from the top view then. Sorry about that. Let's select our geometry, and then from the top, okay, there we go. That gives us a better understanding of the difference between the section view and the silhouette feature. We have this open cavity here, this pocket going all the way through, and it will create, okay, it will create all of the geometry on the inside of it as well as the outside at that specific location. So you can see the top view is exactly right here at Z0, where it's intersecting right here. Then we'll go from UCS. We can either pick or enter. We go with enter, it's a little bit easier. We can change Z-axis. Yeah, so we can change to custom. So we can change from, okay. Yeah, so Z-axis, pointed outward, and we can change the value. Let's see, if we went to 2, should be able to change the plane basically. And we can do that at a certain plane that we select by picking or enter and selecting, like, for example, 2 inches, it'll be an extra inch above. Enter. Oh, there we go. centered. And then it still does the same one outward in the Z direction. But we'd have to either create a UCS or pick a certain direction from an existing surface or an existing UCS. But again, the difference between it here is the silhouette will get everything on the inside and all of the edges that it is intersecting here. The section view will mainly just get like the inside here, and the inner cavity is not going to focus on any edges through it here with the silhouette. If that makes more sense. If I go here to the top right here, in between all of this geometry here, the silhouette will be able to pick this up versus the section view is more of just getting a section view from the 3D model for dimensioning, and that was mainly what it was for, but kind of got away with using kind of got away with using section view for everything, but the silhouette is much more helpful for creating boundaries on the inside of parts and those types of extract edges options there, basically. So we've gone through a good amount of the 3D CAD we wanted to go through today. I'm going to check with the questions or the notes here, and also go through any questions you guys have. Let's see. Here we go. Okay, so before we get into 3-axis milling, I'll go through the questions you guys have. I got a few here. Robin asks, can you unstitch? Yes, good question. I went through stitching. Only right to go through unstitching. So we'll go to where I have just my solid model on the webinar layer. Start with that. Go to create, and I want it to be active, because when we're going through the stitch and unstitch functions, it's going to put that 3D layer, or it's going to put those surfaces onto the active layer that it's on. So I'm going to go to unstitch surface, unstitch solid to surfaces. This is where we just select an individual solid like this here and click OK. It will unstitch the solid into individual surfaces. I'll undo that. And that is different from unstitch surface from solid. You can individually unstitch one surface. So if I unstitch this top surface, click OK, and then go back into my select mode, it's considering all of this a solid still, and now it's considering this a surface. If I wanted to, for example, delete it and see what's on the inside, I guess you could say, if you wanted to, or separate it out, put it onto a different layer. To see what's on the inside. I'm trying to think of other reasons for just deleting or the unstitched surface from solid. It's really just going to be for surfacing options. This is just a flat surface here, but if there was anything contouring and things like that of certain shapes, you want to either delete a surface or go into the Create 3D and extend the surface outward, break it at a certain area, untrim it. You'll want to unstitch one surface from the solid itself, or unstitch all of them all together. Have them individually selected there. Again, if you need to do some other surfacing functions, select one, delete it, trim it out, delete it and resurface it. That's what the unstitch is really used for. That's the main functionality for it. And then the stitch surface to solid is very useful, where you can stitch everything to a 3D model for geometry selection in the CAD functions you saw, and also in every 3-axis milling function. You're normally selecting your solid model, so very easy to select once you stitch everything together there. Alrighty, so unstitch. Worked on your V33s. The file you share next week, will it work? I didn't get my 34 update. Okay, so for Bradley, sure, I will do a V33 file, no problem. I'll actually, you know what I can do? I will actually make it a, okay. So I could either make it a step file, which wouldn't have the toolpath in it. The step file will only save the 3D model, or I can save it as something like a 32 file or 33 file for you guys that don't have 34 yet. I'll have to think about that one, but yes, I will make the 3D model compatible for everybody there. For next week. Next week I'll have a 3D model like this for you guys. I'll put it in the comments section as a Google Drive download link. You can download the file and then place it into BobCAD to follow along next week. Maybe a little bit better there. But anyways, yeah, we will go into the 3-axis milling now. If nobody has any other questions, I'll just double check here. Okay, so go back to 3-axis milling. Sorry, I gotta go to my notes here for a second. Stock and workpiece, drive facing cycles. I know there was a point location, machine flatlands. I'm gonna go over those few first. The ones that I know that I normally use for a demo here. Okay, so here in our CAM tree, we've already got a group of different features of milling operations, and then example 2 of advanced roughing, advanced Z-level finish, and an equidistant toolpath here. You know, now that I've got all of these CAD features here, I know that this solid has moved on me since the origin of the file. Let me close out of it and reopen it. 3D milling example. Alrighty, 3D milling example. So we'll go through the advanced roughing and going through drill tip position. So the drill tip position option is where you can plunge down into a location first before doing the roughing operation to start at that location, a drill move, and then getting into that area that was drilled and roughing out from that entry location for 3-axis roughing, and then also machining flatlands. We'll start by going to a new milling job. We'll just go to CAM and start a new job. Go to milling, defining the machine we're using here, defining our workpiece. This isn't stitched together, so let's go back to create 3D first, stitch, and OK, and different color. Now we'll go back to CAM, new job, stock wizard. Now, when I'm highlighting over the 3D model, it's highlighting all of it automatically for me. When I'm selecting my workpiece, that's showing that this 3D model is an actual solid. It's not multiple surfaces here. I've actually stitched all of the surfaces to create it a solid. And now we'll go to our stock definition page. That's where I can change it from rectangle to cylindrical stock type. You don't get these options in the Mill Express, only in the Mill 3-axis Standard and the Mill 3-axis Pro. You only get rectangle, where you can change the dimensions here. Yeah, it doesn't really make a difference for the Mill Express, only because you're doing 2.5-axis machining like we went over last week. This one's going to be 3-axis machining, where we can follow along surfaces like these tapered walls here. And then we can also define our stock, letting the software know how much material is exactly remaining to get down to our finished 3D model. This can be very helpful if I select an existing solid model, say if this was the casting of it, or if I have an additional 3D model of the casting, I can lay it over on top of this 3D model and select it here to let the software know, okay, this is, for example, if there was only a difference between the solid model I just selected and my workpiece. Say, for example, this is the area that's remaining, the extra amount in the solid model I selected. The software can understand that and mill out just the remaining stock that I've selected here. And also, if you're cutting out of a sheet, this is kind of going back to Mill Express, we're cutting out profiles of parts, and we have a remnant sheet remaining for laser, plasma, water jet, or for a router. We can define that wireframe. We can sketch that remnant sheet and select it here. That way we can calculate that stock. Say for example, this is my remaining stock here. I would just go back into the stock wizard, go to wireframe and select only this here and calculate stock. That way, if that was the remaining area of the sheet, for example, and I can fill in parts in this sheet, I can do that here very easily with the stock wizard. So I'll go back to that rectangular stock that forms around my 3D model. And then the last page is our machine setup. I think we went over this last time, but it bears repeating. This is where we're setting our work offset. I click on origin here and click on a certain point that I'm setting my work offset at. So with your work offset, if you're touching all of your tools off here at this bottom left corner of the stock, for example, then you would click here at this point to set XYZ0 in the G-code right at that location in the G-code, as well as where you're programming it here on your machine or anywhere else at your machine. For example, if you touch the tool off here at the center of the stock, you would just click on that point, and that would be your reference point in the G-code, as well as your reference point at the machine, your reference point on the table there for XYZ0. So from there, I'll go to my existing milling job here. We've got some features, but I'm going to create a new feature to go over all of it with you guys. Here in this file, we start with a facing operation. We go to a center drill and drill operation. And then advanced roughing on the outside. Advanced roughing down towards the center on the inside. Here's one with a drill tip position, another one with a drill tip position, kind of another semi-finish option. And also advanced roughing with operation stock. So something like I was explaining, very similar to the, very similar to the setting it up as a casting. So instead of just this area, we added this area too as our operation stock, which is another option similar to the stock wizard. And then our advanced E-level finish and equidistant toolpath also along those areas. So within this next hour, I can go through a lot of this stuff here. So we'll start with the advanced rough, and we'll start by right-clicking on our machine setup, where we have our different milling operations, drilling and tapping, our 2-axis milling operations, which I'm not going to get into today. We went over that last week of the pocket, profile rough and finish, facing, engraving, those kinds of features there. If you guys have any questions relating to these features, anything in particular, go ahead and leave it in the comment section. I can get to it at the end of the webinar here for any questions you guys have there. All right, so right-click on Machine Setup, and we'll go into Mill 3-axis. Select our geometry, and select our boundary. Here at this stopping point, I'm just going to take a look at the comments real quick. Just give me 1 second. Okay, sorry about that. I will close out of the comments. We're all good here. And we'll go back to the geometry selection is where we are, so geometry selection, we always advise users to select the whole solid model here for your geometry. And then if you want to select a boundary for your finish operation, or if you're just containing the toolpath inside here or on the outside, you don't necessarily have to, you can set the boundary as these edges and then create an outside boundary for what you're containing your toolpath in. And again, we always select the solid model because if there was anything protruding, if I try to make something real quick here to give a visual aid here. So I'm going into Extrude Boss to create a boss for a visual representation. It's very hard for me to select these to extrude out. I was going to go over this earlier in CAD, so may as well do it before I get too far into milling. There are a few other shortcut keys here for hiding the surfaces, for showing wireframe, for different options like that. So T is for transparent, so you can see the holes in here and any other openings here in the solid model. S is for solid, or shaded, I should say. It shades the solid model so you don't see the surfaces anymore. You just basically see all of the wireframe that you're working with, or you can also pick up the 2D wireframe that I'm selecting for an Extrude Boss. That will work well. And then I just click S to hide or show it again. And then one last one is W for wireframe. So it shows you the wireframe along the surfaces of a 3D model there. So that was W for wireframe, S for shaded, T for transparent. very useful shortcut keys there for surfacing, for extract edges especially, and yeah, selecting certain entities that you couldn't get to, where a surface might be blocking it. You can just hide and show it there. Some other shortcut keys I could go through really quickly too is holding Control and pushing the button, pushing the numbers at the top, 1 through 7. So Control 1 is your top view, Control 2 is your front view, Control 7 is your isometric view. So you can play around with those views as well to help you out, looking at it from a top view, looking at it from all those other different views very easily from a shortcut key. I guess you do have these options now, but it was very helpful with back in the day when we didn't have these icons here. Anyways, we'll go back into milling now. And mill 3-axis. Select geometry. So here's this visual representation. If I'm doing just the milling on the inside of this pocket here, and I selected, for example, just the surfaces on the inside, all of them on the inside. I'm telling the software, hey, I just want to pocket this. The software does not understand anything here related to the 3D model also. So it doesn't know you need to avoid this boss here as well. So that's why we always select the solid model so that the software will understand when it's retracting and needs to go from the outside to the inside, for example, or has to do any kind of linking between this boss. It will understand that this is here, retract above the boss, and go down to your next milling location there. So it will avoid any collisions if you select your solid model and select everything that is within the fixture here, or within the solid model that you've got. Also, speaking of, with this workpiece, or the stock I should say, you can select all of that. You can also create an assembly. We're not going to go too far into it today, but you can create a fixture or anything that you have on your table, the device that you're using. You can 3D model that. You can select your fixture here so that the tool avoids that as well. And that's right under your machine setup. You can and kind of go through that, avoiding collisions in any way possible. That's really useful trick there. So from here, go back to the 3-axis and go to our operations. Our machining strategy is just going to be advanced rough. If some of you guys only have the mill 3-axis standard, I will go through explanations of what we offer in the rough, in the advanced rough versus the standard Z-level rough. And if you guys are interested further, just let us know if you want to upgrade to the 3-axis Pro. I normally go through an advanced rough and advanced planar so that we understand the differences between the Z-level rough and the Z-level planar. But we can go through that another time. We're just doing the advanced rough for now. Setting our work offset number. So number 1 is G54, 2 is G55, 56, and so on. Whatever work offset you are setting there at the controller. Then we are setting up our tool and our tool parameters, feeds and speeds here. Go into the tool library and select a tool. Select a tool, create the tool number in there and all of those settings there. Then our different cut patterns. These are our high-speed machining options. So this is the first step where it's our 3-axis Pro. You'll have the 3-axis standard with these here. With the 3-axis Pro, you have high-speed machining operations where the tool will start at the center, continually spiral its way out, keeping constant tool engagement the whole time. This offers tricoidal milling. This is also considered adaptive roughing, or in other CAD software programs, dynamic roughing or dynamic machining. I think I went through that in the 2-axis also. But anyways, yep, this is the high-speed machining in the 3-axis milling. It's only in 3-axis Pro, and it includes the morph spiral and the adaptive roughing. We have our depth of cut and step over settings, how far we're going to step down, how far we're going to step over for each pass. An allowance, so we can leave a certain amount of material for the finished pass to clean up. Plunge, ramp, spiral into the material, entering into the stock. We have our rest machining option. This is in the 3-axis Pro only. If we had a previous roughing operation, we can set the previous tool diameter and the corner radius. The software will calculate any areas the previous tool couldn't fit into and calculate just that tool path for us. So with this tool, I'm not using that actually. I'll use a 1/4 inch cutter. And here, if I used a 1/2 inch cutter previously, I could set that here, and essentially the operation will start right where we left off from that previous roughing operation I used, and it will avoid any air cutting. So from there, we'll go to our machine flatlands. That's one topic we're going over today, where in this example part file, you can see this flat horizontal area until we get to the pocket all the way through the part. When we go back to our depth of cut of 150 thousandths, we're going 150 thousandths step by step by step. If this surface here doesn't line up at 150 thousandths, it's not going to know. We'd have to go back in and do another roughing operation or do a planar operation to finish off this surface, to finish the depth going down. With this machine flatlands option, it will detect all of the flat horizontal areas like this here and give us an extra step down, even if it's not 150 thousandths. Say it's only 100 thousandths down, it'll do that extra step down here and then get back down to milling out the 150 thousandths down to the floor here, or down to wherever level you wanted to end it there. So that's a brief description of the machine flatlands option there. Can be very useful, especially if you have multiple levels going down and none of them sync up. You don't want to find a common denominator of all of those different floors there. You want to just set a depth of cut and machine flatlands so that you let the software work for you and machine all of the flat lands at every depth on your 3D model there. So from here, you've got your linking for each step over, direct link and S-link, so you start a little bit further back, or full retract. Gauss check page, just like we did with selecting the fixture, just like we did with selecting our geometry so there's no collisions. We want to make sure there's no collisions with the tool and with the tool holder. So we would check the surfaces here. I'm sorry, this is in the 3-axis Pro as well. So we went through the high-speed machining functionality in the 3-axis Pro. The entries, the lead-ins, you have some settings there that are different from the Pro versus standard. Rest machining, or rest roughing, and the machine flatlands are all in the 3-axis Pro, as well as the Gauss check page. So we would check the surfaces. If the tool, for example, was too short, the tool holder might have a collision into the stock here. We would check the surfaces, make sure that we avoid any areas that might potentially happen. And then also the advanced feed rates. These are in the standard, where we have a convert rapid moves to feed moves. So if we're not able to set a rapid rate at the controller, we're able to set a rapid rate here in the G code change the rapid moves to feed moves so that we can set that rate, and also set a feed rate for linking between groups of geometry. Here is our standard where we have our 3-axis standard milling feed rate. We have some adaptive options here in the 3-axis Pro, where we can set a minimum and a maximum feed rate. And for example, when the tool gets into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load. And that can reduce chattering at the machine, for example. So at every single move, we just let the software work for us and set the feed rate, slow it down so that it doesn't chatter into those corners. Let's see. I'm going to finish this out. I have the geometry selected. I want a boundary selection here so that I can do the 3-axis milling on the inside of the part and not focus on these corners at all. So we'll go to the boundary, and I can go over this topic that I went over last week that I know of, but it's very useful here, especially when selecting a boundary. Right-click, go to select, and I can right-click on an edge of a surface. So this kind of goes away from extracting the edges there for other layers. As useful as that can be, this is also very helpful where I can right-click on a surface, and there are two options. We have constant Z and loop selection. So if you guys have forgotten this from last week, a good refresher where we can select constant Z as long as every edge of the surfaces for the chain selection here are at a constant Z level. It will pick all of them up for me, so that's my boundary that I wanted anyway. That works out very well. I'll delete that selection for now and go over the loop selection. Let me go over here to this surface. Might be a little easier to get an understanding of it. So from this top, we'll go to loop selection, and then there's different highlighted edges of the surfaces. So we're seeing the chain going all the way around of that Z loop selection, but we're also seeing some surfaces here that are highlighted. What it's showing is, or what the software is asking really, is what loop selection do I want? Do I want the loop selection from the top view, or do I want the loop selection more from a side view here, or from this surface? So if I select any of these edges from this surface, it'll chain select all of those edges for me automatically. That way, if I wanted to create a boundary or create wireframe and select that, or not create wireframe, sorry. If I wanted to do a profile around this, or any kind of, it could be more for multi-axis machining, I would say, where you would select something, some kind of edges of a surface for a boundary from the side of a part instead of looking down on it. So we'll go back to constant Z. That will be our boundary selection, and click OK, and then compute the toolpath. Pick the top of the feature as at the top here. And change something else here. Wonder if it's some kind of setting for adaptive roughing, I believe. So let me just change that. We'll still have that machine flatlands in there. Yeah, it's still doing it with parallel. Let me just go back into it so we don't waste any time here. select geometry, select boundary, and advanced rough, and 1/2 inch cutter for this one, adaptive roughing. Instead of clicking on every single thing here, I am just going to stick with machine flatlands. That's what we were trying to look at today. And pick top of feature. There we go. Now something is starting to compute. If we zoom in here, you can see with that machine flatlands option, it looks like this depth is 150 thousandths and this is 150 thousandths, which it should be. But this looks like the depth is a little different here. Maybe I can change it to 200 thou just to see if there's any bigger difference here. Oh, I think so, definitely. If we look at it here, this is 200 thousandths down into the part right here as we're going around. And then we get down to the next depth. And we're not focused on the flatlands yet right here. Well, it looks like we are right here at least. But then when we get down to the next level, I don't think this is 200 thousandths, which was kind of my point. So we start here at 200 thousandths at this level. And then we go down 200 thousandths again, down to this level. And then we go down to this level, which looks more like 100 or 150 thousandths from here to here, versus here to here is 200 thousandths. So maybe 75 to 100 thousandths would be our next depth of cut, so that we can focus on this flatlands area, make sure all of that is roughed out. We don't want an extra amount of material on the top there with this roughing operation. Save us some time there. So that was the functionality for the machine flatlands. We'll go through the drill tip position. Get rid of our fixture. And let's get rid of all of the toolpath here. There we go. Cool. So we've got a couple points that we've already got pre-existing in here. I mean, really what you have to do is create a point in here. And another useful tip here is you want it to be at the specific depth that you want the drill to go down to for the drill tip position function here. You set it here at the Z0, it's just going to touch right there at Z0 and not do anything for you. You want it to go down here in 4 inches or however far that is, or however far you want it to go down to. If you don't want it to go down to the full depth, you can create a point in between these two depths to let the software know how far down exactly you want to go. And that's done here in example 1. Start with the facing operation. Instead of separating all of these out, well, here now that I've got a facing operation, I'll get rid of this boss. There we go. So now we've got the facing operation, we've got the drilling operation, and again, if you don't want to do all of these features separately, for example, I guess what I'm referring to really is the drilling operation. You've got a center drill and a drill, and then you've got the advanced rough. This advanced rough has this drill tip position option, so you can avoid the drilling options there, and just go right into the advanced rough. I don't think there's any setting in here in any of the pages for drill tip position. you have to actually know where the location is. It's actually not in the Mill 3-axis wizard. If we finish out of this, it's after you expand the feature. So here in this advanced rough, you drop down the advanced rough operation, which, as a side note, is where you can backplot the operation individually. You can change your boundary here for the specific operation, and also change the drill tip position. So right here is where we selected that point. This one down here to the bottom. And then basically all we had to do is recompute it after we've got all of our settings that we want in here, the depth of cut, step over amounts, any other settings there. We would just hit compute, and then we would have our toolpath here, where first we would have drilling down into the stock, and then going down and do it using an advanced rough for the rest of that area there. So from there, yeah, so it's right after the drilling operation, you're setting exactly where you've drilled out. So here's a better representation. So here's drilling, and then drill tip position. This is where you want the tip of the tool to follow down into the part where you've already drilled, so that you can start there and use the side of your tool only to mill out the and rough out the rest of the area there. So very useful drill tip position. Instead of having the software calculate where the entry point is, you can manually tell the software where you want that entry point to be, and be able to start from that drilled hole and work your way outward. I will check the comments here after drill tip position and machine flatlands, and also check my notes, see what else we're going over today with the 3-axis milling. Non-center cutting, let's go with that next. We did drill tip position and machine flatlands. Operation stock, which we kind of went over, I'll go over that again, and non-center cutting using point locations and use stock. Yeah, let's go through the non-center cutting and the operation stock. And let me check the comments section here real quick, see if you guys have any questions. All right, we'll keep pushing forward. Now with 3-axis roughing, with the advanced roughing, we also have non-center cutting option. So this is on the outside of the stock. And if we backplot it, so again, I'll expand this feature. And we've got the advanced rough. Right click, go to backplot. And we can see, based on the stock, if I show that, the cutter isn't doing any of those options that I said of plunge, ramp, or spiral into the stock. It's actually starting from the outside and using the non-center cutting part of the tool to cut into the stock here. So that entry option is also in there. It is that checkbox in the advanced rough. So I'll just work thoroughly through it again. From mill 3-axis, select geometry, select boundary. Select advanced rough. Selecting the tool. the cut pattern. I believe this is only in the high-speed machining. Let me check. Nope, it's in the standard stuff also. So when you go to leads, instead of plunge, ramp, line ramp, spiral ramp, zigzag, profile, you can go to center cutting tool. And all you do is uncheck that box and compute, and it's as simple as that, where you have the non-center cutting part of the tool entering into the stock there. And yeah, so you've just got your geometry there, and you do not have a boundary selected to just do the outside of the stock here. Pretty simple, but it's a good thing to know to for the outside roughing of a part, where you don't want to plunge in, you don't want to ramp in, you want to start from the outside and do a side roughing routine there. Next one is, let's see, so I've done all of these. Operation stock. We will go to operation stock. So again, that was kind of what I went over. I think I have an example of it in here. Not this one. No, this is the one I made. Here we go. So this is another advanced roughing operation. It's kind of a semi-finish operation where we are where we're focusing on a certain area here. We're assuming we've already milled out all of this area through the stock, but we want to focus, like I was kind of getting after before, we want to focus on this area here and this area inside here as well. We've roughed everything else out in previous operations as an example. We've gone through all of the settings here, setting the tool, setting the cut pattern, depth of cut, step over, and also that it's doing a side roughing routine in here. We've roughed all of this out already. It's going to start on the inside here, work its way in to the stock that hasn't been cut yet. Rest machining, Gauss check, advanced feed rates, all of those settings are in there. So it's just like the drill tip positions option. It's in here in the CAM tree, where we have to expand the advanced roughing feature, expand the operation of the advanced rough. We have our boundary, drill tip positions, and operation stock. So you can look at this here. It's already been selected. It's showing the stock that I've selected for this model here. So if I go into a different one, I don't want to mess this one up. If I go in here where there's a, well, I guess I'll start from the beginning, where there's areas here. Say for example, see, just the difficulty with this is creating. Well, you know what I could do? This goes back into creating a new layer and making everything separated from that. I'm going to copy this one and then hide everything. Just got layer 5. I'm going to paste this one into layer 5. So now I've got 2, and I'm just going to make some differences with this one here, just so we can get an understanding of what we're doing here. Say for example, this area is what we want to focus on, and say we want to only focus on half of it, for example, just this area. Sorry, everything's blue, so it's hard to just. Okay, so this is green, and we've got this is gray, and the blue wireframe is what we're going to create an extrude boss on again, just like I did before, but I'm going the opposite way with it. Alrighty. See if this works or not. If not, I'll have to hurry open the file. I'm doing a lot of stuff to it. Let me pause the screen for a second here. But anyway, with this operation stock, the definition of that would be the operation stock is letting the software know what stock amount you're starting out with. Like say for example with this one, what stock amount you're left with before the operation starts. We're telling the software this is the amount of material remaining out to here. Just focus on this area. And I'll do one from start to finish on my own if you guys want to follow along here. Again, I'll add a new layer. Okay, this isn't stitched together, so we'll stitch it together. So I've got this one on layer 5. Put another one on layer 6. So I'm going to manipulate that one. Layer 6, and I'm going to change it to gray again. Color gray. Okay, and then I'm going to create some geometry to create an extrude boss with. I just want to focus on areas right here. Let's make it a little smaller. Make it look halfway decent here. Okay, and then extrude boss. I'm gonna chain select here. Works. Oh, it really doesn't like me adding into this 3D model right at this location. Let me go back to the original file here. But essentially, you know, I really want to make another solid with this. But essentially, it's the same thing that I'm doing, this solid model, in this file. Oh, go to recent. Basically, what we're doing in this feature is we've created extra geometry. So basically did an extrude boss like I was just doing here, and created an extrude boss going all the way down here. You can even see it's going through the hole, is going through this area. We can neglect that because the tool's not able to get to that point anyway. So yeah, we just selected that existing solid model. Say for example, I mean, I'm just going to let me make it. I really want to make it different than just a rectangle. I don't know. That's okay. Let me just go back to layers. Really want to start this from the beginning and start it from scratch and go through the settings here. So that you guys know what I would be doing. All right, now we'll just say, for example, got this wireframe, extrude boss. Yeah, this file itself is just giving me a pain now with 3D modeling. Sorry about that. Let me just get back to where I had left off. So again, a good reason why we have saving. So we just go right back to where we left off here, and then we'll go back into the CAM tree. We'll go to that feature that I have for operation stock. So again, if you could imagine, it's going to be using this solid model, using an extrude boss to extrude out this area right here, so that we can let the software know that this extra amount has stock on it. And from the beginning, using an advanced ref, setting the tool, setting the certain cut pattern, gouge check, advanced feed rates, machine flatlands are all in here. Once we compute, we would expand the feature, expand the operation. This is where we have our boundary, drill tip positions, and operation stock here. So this is where I would select. I could select it as a solid model, as I did here from a previous part file, or I could select it as an STL file, and I can just browse my computer. I should have an STL file here, actually. So whatever these are here, let's try stock. So this is a different CAD file that I had, something similar, but it's a mold shape, and it's a lot larger. So that's what I could use and let the software know that was a file that I had already saved. There was extra material like we have right here exactly to focus on versus doing any air cutting from anywhere else inside of the pocket here. We're just focusing on this area here. After we hit compute again, then it will compute the toolpath pertaining to the operation stock. And I guess we can just backplot this, and then we'll take a look at the simulation. Now again, these features in here are grouped together just like we had our layers grouped together. Go into machine setup, and it's under additional functions where we can add a group, just like we have here. And then we can drag and drop the features into the group, just like we did in the layers section. So we start with a facing operation for this part file, a center drill and a drill, and then setting up the drill tip position here so that the tool will start right at the center of the hole that we drilled and do a side roughing routine for that. And then kind of going through some other features here. Okay. Going through some other finishing operations here. Oh, let me change the machine here. On destination. We've had some trouble here. Didn't have as much trouble as last week. I barely had any trouble at all. How do Please uncommit. Oh, I think that was the fixture. I had it reset before. Okay, there we go. So our simulation, just as we did last week with the Mill Express, we have our estimated cycle time at the top, 16.5 minutes. And I'm going to run through this with the facing operation first, then the center drill, end drill. That was very quick. Then the outside, and then the inside here. Now with this, if I restart it, actually I should be able to go through everything now. And I'll slow it down for the things we went over today. We'll skip through the facing, and then we'll get right to the drill operation next. So that was the drill, and then this is the, let me pause it here, go back to that operation. This is the first advanced roughing operation. And this is the one with this is one that we went over today, the outside advanced rough, where we selected a non-center cutting tool option in the settings there as our entry option. We uncheck that box for center cutting tool. Let's go there real quick. That was inside of the Mill 3-axis wizard. This was the one that was actually inside here. And it's under the leads page. We uncheck that box, center cutting tool. So we went through the facing, went through the center drill, and then here is where we start from the outside of the stock and work our way in. If we didn't have that, if we had that box checked, it's a little confusing. If we had that box checked for center cutting tool, then the tool would either plunge or ramp along the side of the stock here. Since I have unchecked that box center cutting tool, it starts from pretty safe location there. Think about a 1/4 inch. I think it's half the diameter of the tool. It's either the radius or half the radius, I believe. Will be away from the tool, the tool will be away from the stock, work its way in for that entry option there. And then the next one is the drill tip position after this operation, is where the tool starts right at, go back, slow it down. The tool will start right at the drill tip position that I selected. We'll review that also. Drill tip position. It's not in the CAM 3-axis milling wizard. It's where you expand the feature, expand the operation, and then select the drill tip position here, and you would select that point created for your operation there, and then right click and compute again. Compute the toolpath for that operation. This is right after this outside roughing. This is right where we start at the drilled hole location, run it, and then work our way in and use the side of the tool instead of using the bottom of the tool at all for this operation here. That's the best benefit for the drill tip position and non-center cutting tool option there. you're not using the bottom of the tool to do any of the roughing here. You're using all of the side of the tool here. Then the last one, operation stock, was after a few of these milling operations. Got down to the bottom. I think we went down to the next depth here. Yep. And then after everything's finished up, we're just letting the software know now this is the extra material remaining. Just focus on that area. By creating a solid model and using an extrude boss, this one looks like we could do a little more work on the corners there, but you can see here it's getting better with the semi-finish here. Getting into the corners, we just need to use a smaller tool next for this finish operation here and getting further down into it too. But yeah, again, that was the operation stock, which is also here in the CAM tree and not in the 3-axis mill wizard, where we go here, where we expand the feature, expand the operation, and operation stock, reselect, select the STL file, or select a solid model if it's a solid model here in the software program. We would select that, click OK, and then compute the toolpath again. And that was the toolpath that was focusing just on that area, working to pocket down into these 3D surfaces and all the way around here as well. Instead of doing any air cutting and doing anything like that inside the pocket that we've already milled. Now that's about it. After the simulation, again, just post the G-code. It'll generate the G-code here, save, send it to the flash drive, and go from there. And just checking on my notes real quick, that looks like a good stopping point, especially since it's 3:01 here in Florida. And just wanted to take the time to thank everybody for attending the 3D CAD and 3-axis milling portion of the webinar here. We went over that 2D and 2-axis last week, 3D and 3-axis this week, and we're going to kind of progress from there each week, Wednesday, this time to go through everything. If there's any questions that you guys have, please let me know. I'll go through them. Mark said thank you. Thanks, Mark Rowland. Always going through the webinars. Okay, and that's about it for the questions. Again, just to go over everything, my name's Eric. Went through, I normally do the demos of the software program and also do tech support with the guys too here. And what we went over today here, the 3D stitch and unstitch. Then we went through extract edges, project curves, silhouette, and we went through 3-axis milling with the advanced rough. And just going back through it, most of these options are with the 3-axis Pro. I want to just double check with Z-level rough if there's anything in here for it. No. So the drill tip position, the stock, drill tip position, operation stock, non-center cutting part of the tool, and the machine flatlands, all that we went over today, that is all going to be in the Mill 3-axis Pro. So it's a pretty good selling point if you guys are on the standard also. If you guys followed along with what we went over today and interested in that, please contact us to let us know if you're wanting the 3-axis Pro. And yeah, just kind of going back. Thank you guys for attending today. We had at most 22. We're at 18 now. But yeah, just want to thank you guys again for attending. Thank you for bearing with me. It's only my second webinar. Technically, I normally do the demos, and that's more of a selling environment or a selling type of attitude that I normally have. So going a little further in depth with this, it's not necessarily my strong suit at the moment, but you know, it's only my second webinar. I'm going to be going through next week's webinar as well, same time, same place. And again, thank you guys for attending, and hope you guys have a great rest of your day. And I'll answer any other comments in the chats there as well here. Thank you very much.